Yeah, so Alex says we all use it. How many of you have used rustls as a dependency in your project? That's a fair amount. How many of you are still using OpenSSL somewhere in one of your projects? And why? So that's the really interesting question. So I'd like to hear your use case where you're still using OpenSSL later today. But first, let me talk a little bit about what rustls is and does and why you should use it even more. So quick bit about me. I'm a CTO at Instant Domains, a startup where we're building a product for small businesses to get on the internet quicker and make money there quicker. I've been a rustls co-maintainer for about 2 years now. I did a project for the ISRG, so the organization that backs Let's Encrypt originally, and they have this Prostimo project where they want to make lots of stuff more memory safe, and one way to do it is Rust. And so rustls was actually one of the first projects along with the Rust in the Linux kernel project. And so I did about 6 months of that. I implemented some stuff which I'll talk about later. I also maintain a whole bunch of other stuff. So some of the more popular ones are Chrono, the Trust DNS suite of DNS crates. Indicatif is a progress library for the CLI. And originally the way I got started on rustls 4 years ago now was when I started to enable Quick support. So Quick is a newish protocol to replace TCP. Essentially it's used in HTTP 3. And I started an implementation in 2018, and Quick, it turns out, needs TLS, but it needs TLS in a different way than for TCP. So it needs like a completely separate API that at the time really no SSL library provided. And OpenSSL to this day does not provide the Quick API, so that's fun too. But we hacked it into rustls pretty early, and that's how I got started hacking on rustls a little bit. So what is TLS? If it's not thread local storage, it's always confusing. So this is basically the protocol that's used to safeguard traffic on the internet. I think it was started many years ago at Netscape, probably like more than 2 decades ago. And of course, the prevailing implementation is OpenSSL, which I think was hacked up by a student also in '99 or something. So the protocol is transport level security. So basically you use TCP and you put a layer on top of that where you have a messaging layer cutting up your stream, your data stream, into messages of about like 16,000 bytes. The latest version is TLS 1.3, which was quite a big change because there were quite a few problems in TLS 1.2 and earlier versions of the protocol, and for 1.3 they did a whole bunch of work to make sure it was more secure. And so that has also been really good for reliability. It's easier to start a session because the handshake is quicker to do. And so why would you use it? So 3 things: authentication. So is this the other side that I want to talk to and that I expect to talk to? Confidentiality, so can anyone else see your data, like any of the middle boxes along the route? And integrity, data cannot be modified by attackers. And so one thing that's often seen that can be an issue, like a lot of people just disable certificate verification, right? Because it's a pain in the ass. You don't have a certificate from a CA, maybe there's not a stable server name that you can use. But really the confidentiality isn't worth much if you don't do authentication, right? So if you don't know that the other party is the party that you want to talk to, then some attacker can man in the middle to you and put some box in the middle that terminates your TLS connection and then passes it on. And so your connection is no longer confidential, even though it's still like TLS. So you should probably find a way to do authentication, and there's usually a way to do that. That's probably not an improvement.
Now it is.
Thanks. So yeah, and it's also used in Quick, and it's a different framing layer, or rather it removes one level of framing from the TLS, or the TCP version of TLS. So what is rustls? Rustls is a project that was started quite a long time ago. I think the first public release was in 2016. It was started by Joe Pixton-Barr. He's from the UK. You might have seen him at Rustfest sometime. It builds on a bunch of libraries by Brian Smith, one called WebPKI, which implements the certificate verification or validation, and one called Ring, which is a fun name. It usually includes the asterisk when used officially. That's a play on, I think, Boring SSL, which was derived from Boring SSL, is itself a fork of OpenSSL done by Google originally, which has no stable API, but is used by some of the larger projects and is probably more secure than OpenSSL. And well, Brian is a highly capable security engineer, has also made some controversial choices in the past. So maybe we'll talk about that more later. Rustls implements TLS 1.2 and 1.3 support. We don't support older versions because they're pretty crappy. So even the IETF has now officially deprecated TLS 1.1 and earlier, so you should not use them. And it only contains safe Rust in the Rustls crate itself. The same is true for WebPKI. I think Ring contains a bunch of low-level stuff like assembly to do crypto really fast, so it's not as safe, but pretty good. Why use Rustls? I think this is my number one question. So this is just the list of things that were published in 2022. And so the last one there was discovered apparently in 2021. Yeah, and I mean, these were not like, there was this stuff in this month, for example, was advertised as, oh, this is big, this could be critical, and in the end, it wasn't as big as they thought it was. You may have heard of Heartbleed, which is an older one in 2014, where it actually could leak your private keys over the internet. So this is the kind of stuff that really you don't probably want in your application, right? And even like if the severity or the severities aren't that big or aren't that bad, this is just a hassle, right, to have in your deployment. You need to watch this. You need to stay on top of the vulnerability lists and the announcements, and then make sure that all your bits and pieces upgrade in a timely fashion. Well, maybe in the case of these last ones, you shouldn't have upgraded, because if you were still on 1.1, you'd be fine. But yeah, it's a hassle. And so Rustls, by comparison, has had no security advisories so far. That's not to say that there haven't been any like vulnerabilities, but it's nothing like this, right? And definitely not some of the stuff like Heartbleed, which of course, I think that was actually a memory safety thing. So you're probably, given that we're using safe Rust, you're in the clear there. We've systemically made that really hard to happen. It's also pretty fast, pretty efficient. So this is a set of measurements from 2019. I bet Rustls has gotten faster since then. We've done some work. We haven't yet done a comprehensive set of measurements again more recently. That's on the list. Probably OpenSSL might also have improved. So your mileage may vary, but at least by comparison, it should be not a concern, right? We're not massively slower than OpenSSL. So I want to talk a little bit about how we've implemented Rustls to hopefully make it well, or make it work well and make it robust. So one thing, if you like Rust, you may like type systems, or you might like making good use of the type system to make your code robust. And so here's an example of something that we implemented in version 0.20, which is the latest current minor version, which is a safe configuration API, which requires you to make explicit choices about some of the things that you need to do for your TLS configuration. And it also, it forces you to make choices for a bunch of stuff and forces you to input the stuff that you need. So for the client, you need to give a set of root certificates that can be used as certificate authorities. And for the server, you need to provide a certificate and a private key, or certificate chain, really. And some of these other choices, you can choose to accept particular versions of the protocol, key exchange groups in protocol, and cipher suites. But usually, in many use cases, you can use these defaults because they're all safe. Like there's no weak cipher suites in Rustls, which is also different from some of the other libraries. type states can look a little messy, right, in the documentation. So in this case, we're leaning a bit on the type state system, or the type system, where we have this config builder type, and it gets parameterized both with the side, either a client or server config, and with the phase, like you have to do these in particular order. And so that looks a bit hairy if you look at the configuration. So instead, prefer to look at the examples and build from there, and usually you can just copy it. And of course, building this is quite a bunch of boilerplate code, right, if you have to build this stuff. But then we argued about that a little bit, like how much code do you want to support the configuration? But actually, I think it's a usually good trade-off, because this way you have to write that code, and it's sort of boring boilerplate code, but it's not really high maintenance, and it just works. And calling it like this is pretty readable, right? Or is pretty acceptable Rust style, in my opinion. So we use type state in a bunch of other places. So one example is the core TLS handshake. This is just a part of that. This is the server-side handshake. So rustls is really organized in sort of 4 separate parts. You have 1.2 and 1.3 on one axis, and then you have the client and the server on the other axis. So we try to separate all that so that if you use one of the parts, you don't have to get all the other parts. And in particular, for your binary size, it might be really nice if you not have to pull in everything. And so we also try to do stuff like if you pick only a small subset of the cipher suites, you don't have to link in all the crypto for the other cipher suites to keep your binary sizes down. These handshake states, this is basically a state machine, right? A protocol state machine. And so these are actually implemented as types that implement a particular trait called state, because we're inventive like that. And you progress through these states along a particular order. There's one little cycle there in the TLS 1.3 handshake where you can do a restart, or forget the exact name, but you can go back and do a handshake again if in case some parameters sent by the client are not acceptable to the server. But otherwise, this is pretty straightforward. So I'll show you this trait. There's a bunch of interested parts. So this is also new in 0.20. We had before that we had a bunch of other stuff which I'll talk about later, which wasn't working as well. So here we have this state trait, which is implemented by each of these types. It takes a data type, which is basically abstracts over server versus client, right, which have different kinds of state associated with each state machine state. And it takes the context where it has a mutable access to that state, and it takes the message. So that's the protocol message, and it will check if it's the message that it expects, and then let you progress to the next state by emitting basically other messages sent out to the peer. And so the secrets that live in the states are also stored in here, so they can basically only be accessed by calling one of these methods. The export keying material is the first one. So that's actually used if you can pull some secret data out of your TLS session. That's not like the core, like the master secret, but it's a derived secret that you can use for other stuff. And then the secret extraction is actually a new feature because we now support KTLS, where you can do TLS in the kernel. And TLS in the kernel works the way it does, that you have to do the handshake in user space, and then you take out the secrets and you pass them to the kernel, and you can do like all the decryption and encryption in the kernel, which is faster because you have to do fewer system calls. So we now offer this as a feature where you can take all the secrets out of your TLS connection after the handshake, and then shove them in the kernel context and work from there. So more type states. So we have a key schedule for TLS 1.3 according to the spec. And so this is also something where previously we had a bunch of stuff going on where you have types that have a bunch of option fields, and you go and set them or unwrap them because dynamically that they have to be some. So one of the projects I worked on for the ISRG was to eliminate panicking from the code, and I didn't manage to do it all, but a bunch of the unwrapping calls where I was able to extract by having a proper type state here, and again make a sort of state machine that progresses to each state in a way that you know it doesn't fail. And so there were a bunch of places where you have this type confusion, right? Where one type is playing sort of the role of many types at the same time. So there's a bunch of options that are dynamically, you know, something more about them than you know from the static type. And so we had these handshake states, for example, where there were some types that were basically being threaded through the handshake states, but then sort of grew with more fields being set over time, but you couldn't really know that in the code. And connection state, where the connection state also has a bunch of stuff that you know over time is growing. And that's still the case, right? There's over the course of the handshake, you know, for example, the cipher suite that you negotiated, or the application protocol that you discussed, that you talked to or decided on with the peer. And now all of those options fields are basically write only. So they are none, and then at some point they become some, and that's much clearer. And those are usually the fields that are only accessed by the user API, which is also returns option anyway, right? So that's fine. And then the cipher suite states, we also had this issue where we had TLS 1.2 cipher states and TLS 1.3 cipher states, and they used some of the same internal types, which had a bunch of option stuff, which was all kind of messy. And we refactored that into a proper enum, which is TLS 1.2 or TLS 1.3, and then it only has the stuff that is necessary for them. So certificate verification is an important part of a TLS stack, right? This is the part where if the server gives you a certificate as a client, you're going to say, do I trust that this certificate is from that server? And that's basically because you trust a bunch of certificate authorities. And so one question is, which certificate authorities do you trust? And there are a surprising number of good answers to this, right? So one good answer is you pull the web PKI root crate from crate.io, which is basically the Mozilla certificate store encoded as a Rust crate. So you can statically compile it into your binary, which is pretty nice. You don't have any dependencies on the rest of the system. At the same time, if there are changes in that certificate store, that means you have to make sure you recompile. Otherwise, your binary will still have some certificates from authorities that may not be trusted any longer. There's the rustls native certs, which basically pulls the certificates from your platform, your OS certificate store. So that has support for Windows and Mac OS. On Linux, certificate store is usually just a text file provided by your distribution, and it may or may not be of high quality. In particular, the Debian one contains a bunch of crap that you probably shouldn't be using. And now there's a new one. So 1Password also uses rustls a bunch, and in particular in their clients that they also ship on Windows and Mac OS, and probably also iOS and Android these days. And so that's called rustls Platform Verifier, and this calls directly into the verification APIs on the platform. So in Windows, you have, I know, the OS API for this, and on Mac OS as well. So I think that's S-channel, and what's the other one called? I don't remember right now. But so this is actually better, because if you look at the OS certificate store, the OS may store extra metadata about the certificates that are in the store, right? So it may have some particular certificates that is in the store, but that might have some not valid before or not valid after metadata that you're not getting if you're just querying the certificate store. So it might actually be better to use this. And I think we'll start, and this was a recent open source publication by 1Password, so I think we start publishing this more or making this matter a clearer option in the future, because I think it's a pretty good option for software that you're shipping on client platforms. Why not use rustls? So again, I'm curious about your answer to this stuff, but so the number one reason I think is that there's no support for IP addresses in certificates. So WebPKI, the library that does the certificate verification for us, doesn't support this. It was originally really targeted at the web public key infrastructure, and there it's not super important. Like there's really usually a DNS name that you can use. But in a lot of cases, and I think Kubernetes is one that is sort of popular, right? Is you don't really have server names or DNS set up and you just want to use an IP address, and currently we don't support that. Luckily, Joe has another contract with the ISRG where he will be trying to solve this in the next 2 months. I think his contract starts tomorrow. Portability, so the underlying Ring crypto library is really good and really secure, but it's also, it has a bunch of assembly code, at least in the currently published versions, 0.16. And so that can cause issues if you're on a minority platform. It also hasn't seen very much maintenance over the last 6 months to a year. So that's a bit of an issue. I think Brian had some personal issues that he had going on, and now he has started committing some stuff again, so hopefully the situation will improve there. And in particular, in 0.17, in the development branch, there's a bunch of stuff where he started using what's called fiat crypto, which is, I think, formally verified crypto primitives that can be translated directly to Rust. I don't know if that's happening there yet, but at least the portability story there is better. So hopefully that will ship in the not too distant future and we can start picking it up in rustls. And rustls is now abstract over, like it doesn't have Ring or WebPKI in it as a public dependency, so we can basically ship whatever version of Ring and WebPKI we like, and we don't have to upgrade or do a semver breaking version for rustls. So platform verification I mentioned already, so there's now the 1Password option, so it's not as big of an issue. And then there are some like big players who really need TLS 1.1 because they have to deal with, I don't know, embedded platforms that are stuck with crazy old stacks and they cannot upgrade beyond that. So these are some of the reasons that I know about and that we have thoughts about. I don't think we're ever going to ship TLS 1.1 at this point. I just don't think it's necessary for most of the use cases. But some of these other things we hope will improve in the future. In the case of Ring, we've also discussed abstracting all the crypto ability in rustls with some traits, probably involving a fair case of complicated associated types and nested traits, but it could work. We're doing something like that in Ring or in Quinn, the quick implementation to abstract over rustls. So that's something we could work on, but there hasn't been a lot of people asking for it so far. So I wanted to mention briefly all the stuff that we think we could do in the future, if anyone's interested. So the IP address support stop list, already mentioned that. One of the things I've been working on is to figure out if we can make the handshake faster and less memory intensive. So for example, we now allocate right up front for every session a 16 kilobyte buffer just to read messages into, and then chop them off from there. And that's usually not necessary because most of the handshake messages don't actually reach 16K. So for your smaller clients or your resource limited environments, it would be good if we can be more efficient about that. And currently in the handshake, we allocate a bunch, right? We just allocate all VEX all over the place. And I think actually we could use a zero allocation API where you provide a buffer into the connection, which you can read bytes off of, and a buffer that we can write outgoing bytes into. And then we don't actually need to allocate or keep buffers around anyway, and that would be much nicer. There is some details in the session cache API. So caching is quite an important session resumption, right? If you want to be as a client, you want to resume your session from the last time. It's much more efficient, but there's currently some limitations where the spec says you probably shouldn't reuse a session ticket more than once, and I think currently we allow that. So we need to improve the API there, and that will probably take a breaking release to fix that, since that's public API. We offer a trait where you can implement your own session cache. So we want to improve on that, and that's, I think, also on the list for Joe to fix soon. And then one other thing that people have asked for is access to more client certificate details. Currently, we basically don't. You can put your client certificate, and we don't allow you to extract a whole bunch of details out of it. You might want like the email address, or I don't know. I haven't actually had a use case for client certificates myself, but this is the kind of thing you get to consider. Encrypted client hello. So you might be aware of, I think it was called encrypted server name indication first, but now it's called encrypted client hello. That's a spec that has been going on for quite a while now. I don't know exactly the current state. I think it's not particularly near being published as an RFC, but when it comes out, we'll probably want to add support for it too. So it basically makes it so that a bunch of extra details in the client hello are encrypted, so that you're not leaking what DNS name you're connecting to, for example. And one other thing is FIPS support. So FIPS is the US government standard for really good crypto. It's a really interesting standard where you have to go with your particular version through a rigorous, I think, auditing process. I think part of it is automated now, but maybe not all of it. It's a pain in the ass, but it would have value to do that and to cement, I think, the rustls stack as a really good option even for these high integrity projects. So it's something that we're considering, like what it would take to get the rustls web PKI ring stack through a FIPS process. And I think Brian is interested in that. I don't know the current status or progress on that, but it's something that we would like to get done in the future. So that's really all I got. If you've got questions, let's hear them.
Here we go. Does anyone have any questions?
Yeah. So I have something for the. Let me ask it first. Do you have Dane support in rustls?
We do not yet have Dane support. I think there's. It's controversial, at least.
Why?
Yeah, I don't have the details in my head right now, but I think, in general, yeah, I don't remember why. But so there is an issue for Dane support, or like the bits that you need to do Dane support. I think it needs also support in web PKI, which has been a limitation because web PKI has been short on maintenance.
What's the
Sorry,
yes, that's a good question. It's
DNSSEC authenticated named entities. So the DNSSEC authenticates either the certificate authority or provides the public key itself.
Yeah.
The public key
so
comes from
I
DNSSEC.
personally subscribe to the school of Thomas Petacek, who says DNSSEC is a scourge on the earth and you shouldn't use it. And I think he has made some convincing arguments in that direction. But
Well,
let's not have that debate here and now. But in any case, so Dane, I think, would require some bits of support that we haven't gotten around to.
I think it would be quite straightforward to support. You basically only... So I know the API from OpenSSL, and you just provide the hashes, which you got from DNS. And then it has to match, the public key has to match those hashes.
Okay. Well, pull requests welcome, I would say. That's,
So, yeah, one other thing on the future improvements list is the encrypted client hello, which is almost done. And very important, so it should be moved to the top of your list, I think.
I mean, when it gets published as an RFC, we'll move it closer to the top of the list. We really want to have it, but so as long as it's in flux in the IETF, we probably won't.
Well, but you did implement Quick, which only recently became RFC. So
well,
this is another opportunity to be early implementer.
So for me, that was the other way around. I wanted to work on Quick, and then I implemented in rustls.
Yeah.
Right now, I don't have the spare time capacity to implement encrypted client hello, but I think that would come as a high priority once it standardizes.
Okay.
One of the poor souls who is using OpenSSL and rustls,
Okay.
Both. But I'm using OpenSSL to verify digital signatures. And I know it's in rustls because you do certificates, but I just couldn't find the API. I looked at Ring, but okay, it must be in there somewhere, but I couldn't find it. So now I have to resort to using OpenSSL as a process, which is, okay, let's say not advisable.
Yeah, I definitely verify digital signatures with Ring. So that's definitely possible. I don't know like what kind of if you're just talking ECDSA or ED25519 or RSA. Yeah, I mean all of that is available in Ring, and the API can be different from what you're used to, but it's really good. It's very misuse resistant, which is what makes it harder to use. But it's definitely there. So I would check the Ring API documentation. It's in the signature module, and it should be most of it is there. There's no support for RSA key generation yet, but I hear that's being worked on.
Anyone else? Yes.
There.
Oh, you're closest here. I think you said that you're still at the 0 dot something, right?
Yes.
I think we all know that Rust libraries sometimes stay for a long time on 0 dot something. Can you say something about what it would take for you to go to 1 dot something?
More confidence in the fact in our like final API, which I think is tricky, right? Because there's a bunch of stuff. But for example, this 0 or less allocation, like a write-through API, would be quite a change, and that's something that we know that we want to do. In general, personally, I don't see using a 1 point or x.0 something version as a big change from using 0 dot something not too low versions. So I would say don't over-index on the version. I think 0.20 indicates that a bunch of work has been done. I think the fact that there have been no vulnerabilities also indicates that a bunch of good work has been done. I think the performance is like relevant. There is pretty good documentation. Usually if you file an issue, I will respond fairly quickly. So I would say use some of those things to get an indication of the maturity or stability of the project, and don't over-index on the leading number of the version. Any other questions?
No,
Right.
then I have a comment.
Yes.
Because, well, both Krill and Routinator are both at 0.12, which perfectly aligns with what you were just saying. The projects have been around for over 3 years. They get daily maintenance from multiple people, and it is no indication of the maturity of the project at all. The other thing I want to mention is that Krill is an RPKI, so Resource Public Key Infrastructure implementation that provides a certification authority that aids in routing security, so BGP routing security, allowing you to issue certificates stating which autonomous system is allowed to originate a certain block of IP addresses. And for this, the standards dictate that it needs RSA keys. And therefore, we are reliant on OpenSSL for RSA key generation. And we would like to move that to rustls, which we currently cannot do. So that's what we're talking to Brian about.
Yeah. Yeah, that's great to hear. I mean, at least for key generation, you can often sort of do it out of band. So that's something that I would advise. But yeah, obviously being able to do that in Ring would be better.
Yeah. Yeah, it's interesting in a way because as an organization, Nelnet Labs has mostly just implemented things for others upon request, and this is basically one of the first times that we're reaching out to some other another open source developer to implement something that we actually need for one of our implementations, and then give that back to the community for other people to rely on, which is actually pretty cool. Anyone else have any questions? No? And then with that, oh, we're right on time, I can't believe it. So I want to thank you all.